Package management. In this nugget, we're going to talk about the two most common tools to manage software packages on a Linux system, the Red Hat Package Manager and the Debian Package Manager. First, the reason we want a comprehensive tool for package management is because it takes some of the organizational burden off of the system administrator by keeping track of important dependency information. A package management tool really helps when there are multiple system administrators at a large installation. It allows them to efficiently coordinate their day-to-day software management duties. So let's get to work. We're going to start our discussion of package management by talking about these two tools, and they're the two most common tools in Linux that people use to do package management. The first one is called apt, and that stands for a package tool. You don't get a much simpler acronym than that. And that was developed by the Debian Linux people. And then there's RPM, which is the Red Hat Package Manager, and that was developed by the Red Hat distribution. Okay, now this doesn't mean you need to be using Debian Linux to use the apt tool. Other distributions of Linux have adopted apt as their own package manager. Okay, and what we're going to talk about today in relation to apt will apply not only to Debian Linux, it will apply to these other ones as well. And Storm Linux and Corel Linux are two versions or two distributions of Linux that I know have adopted apt as their package manager. Okay, and the same goes for RPM. You don't need to be using Red Hat Linux to use RPM. Mandrake Linux, SUSE Linux, Caldera Linux all use RPM as their basic package manager. Okay, so let's start by talking about the Debian package management tool. And what we're going to do first is look at the basic commands that we use in Debian to use this apt tool. The first one is deselect, and this is a front-end interface for apt. Okay, so if you like to point and click and use menus and things like that, then deselect is the way to go. If you want to type commands at the command line, then you would use apt-get and depackage. Apt-get takes care of getting packages from a CD-ROM or from the internet onto your hard drive, and then depackage is what you use to install the package, remove the package, get information about the package, that sort of thing. So depackage is where most of the work gets done. Apt-get just gets the packages from the CD or the internet. So we're going to focus here on the depackage command because that's where most of the meat of this package management tool lies. Okay, so before we start talking about the depackage command, let's look at the format of Debian packages. So here's the name of a Debian package, and the first part of this is the actual name of the package, like sendmail. Okay, the second part of the thing here, the number, is the version of the package. So 8.12.3 is the version of sendmail that we're talking about that's contained inside of this Debian package. Then 6.6 over here refers to the Debian version, so the version of Debian Linux that you should be running to get this package to run. And then the .deb on the end just lets you know that it's for a Debian package as opposed to a Red Hat package management tool, like that would end in RPM. Okay, so that's how you decipher a Debian package name. Now let's look at the actual commands for depackage. Now the depackage command has lots of options. Most of the options that come with depackage have a short version like -i and a long version like ---- install. Okay, so if I was going to install that sendmail package that we just looked at, I would say depackage -i and then follow that by sendmail _8.12.3, etc. Okay, I could also say depackage ---- install. So this is good if you don't remember the one-letter shortcut for the directive that you're trying to carry out as part of depackage. Then there's ---- configure, which reconfigures an already installed package on your system. Then there's two commands here that are important for removing packages, -r and -P. They both remove a package, but you can see here that -r or ---- remove removes a package, but it leaves behind the configuration file. Now, why would you want to do this? Why would you want to leave behind the configuration file if you're removing a package? Well, one reason you might want to do that is perhaps you're going to install from scratch a brand new version of this package, okay? But the old configuration file was very tailored. It was very specific to your setup, and you put a lot of work into that configuration file. So what you can do is remove the old version of the package with -R command that leaves behind the configuration file. Then when you go ahead and install the new version of the package, the old configuration file is behind. Now there might be some instructions in the new package saying, well, in the old configuration file we did things this way, in the new one we do things this way, but often they try to make those backwardly compatible, so the new versions of a package can use the old configuration files. That saves you a lot of work, especially if, like I said, it's very tailored and specific to your system, the configuration file. -P or --purge takes things a step further. That removes a package including the configuration files. So you use this option to depackage when you want to just get rid of it altogether. You're not going to be using this piece of software anymore, so you just get rid of it altogether, including all of the configuration files. Then there's two commands to print out information about packages. -P, lowercase p, which is also called --print avail, prints out information about already installed packages. And then -I or --info prints out information about uninstalled packages. Okay, so these are kind of grouped together. These two remove packages. These two you get information about packages. The kinds of information you'll get from these commands are things like versions, release dates, information like that. What files are part of the package if it's already installed, things like that. Okay, now there's other options for the depackage command that are useful. The -L option, lowercase l, and I've just written that in script so that it doesn't look like a number 1, followed by a pattern. And what that will do is that will list information about already installed packages whose name matches this pattern. So if I say depackage -L mail, that will print out information about the packages that have the word mail in the package name, like send mail. Okay, capital L will list the files associated with a package. So you look at all the installed files on your system that are associated with a particular package. Okay, so this gives you some information about what all this package includes, right? The sendmail package doesn't include like one file called sendmail. This is why we're doing package management, right? Because there's lots of supporting files for the sendmail program, and the capital L option is what will tell you all those various files that are associated with that sendmail package. Then there's -C or --audit, and this will look for partially installed packages on your system. So perhaps one day you were installing a package, there was some dependency information that wasn't met, and so it didn't go through all the way. Then you got distracted and went on to something else. Well, what this will do is this will look for all those partially installed packages that are eating up disk space, so you don't go ahead and either try to reinstall them, or maybe you ran out of disk space one day and you're looking for ways to get some disk space back. This would be a good thing to do to find unused stuff on your system. Okay, so there's the depackage command set, and like I said, that's useful on Debian Linux, Storm Linux, Corel Linux, as well as some other distributions of Linux. Well, let's start our discussion of the Red Hat Package Manager, again, by talking about the format of an RPM file. Okay, and it's a lot like the Debian format. Okay, it starts with the package name. So in this case, we're talking about the Samba package, the thing that allows us to interface between a Microsoft file system and a Linux file system. Okay, following the Samba is the version of Samba. So 2.0.7 is the version of the package that this file name refers to. Okay, so these version numbers work like all the version numbers that you're used to. 2.1.0 is a later version of Samba than 2.0.7, and so on. Okay, following the package version is a dash, followed by what we call the build number or the release number. Now this build number and release number confuses people sometimes because this number is not really sequential, okay? Like if there was a, Samba 2.0.7-14 out there, you'd think, oh, I want the -18 version because it's newer than the 14 version. Now that's not necessarily true. These numbers don't really represent like a better version of the package. It just represents a different build of the package. And the reason you want different builds of packages are for different subtleties, okay? Like for like I was saying earlier, the RPM package manager is used by lots of different Linux distributions. One of those distributions is Mandrake, okay? So perhaps there's a particular build of the Samba package that is for the Mandrake distribution. So it could say, this package name could say something like Samba 2.0.7-14 MDK. This represents a particular build of the Samba package for the Mandrake distribution of Linux. Now, why would we need a build specific to Mandrake? Well, here's why. Perhaps the Mandrake distribution of Linux has some different names for certain libraries, and maybe the Samba package uses those libraries. Okay, so if you just ran the regular old one here and you tried to install this on your Mandrake system, it might come up and say, hey, missing libraries. When those libraries are really there, it's just that Mandrake calls them something different, or it puts them in a different subdirectory or something like that. So if you're running the Mandrake system, you should always look for a particular build that has this MDK qualifier on it, and that lets you know that it's for the Mandrake system. And even if there's a number out there like a -18 that's larger than your -14 MDK, this is the one you want. It's really no different than the -18. It's just a different build. As long as these versions are the same, you're talking about the exact same version of Samba with some different subtleties underneath that you don't really need to concern yourself with. Okay, this is one of the beauties of having a package manager. You don't need to worry about all these different library names and the locations of these libraries and things like that. Somebody's already taken care of that for you, and they've labeled their build accordingly. Okay, so the next after the build number is a period followed by the architecture name. Now here I've written i586, okay, is the architecture for this particular package. Now i586 refers to the Pentium, okay, i686 is the Pentium 2. All right. The most common thing you'll see in this field is i386, and that refers to an Intel 386 processor or later. Okay, so if you see i386 in this field, it's going to work on 386s, 486s, 586s, 686s, all the various different architectures that are out there that were based off of the 386 architecture. Okay, whereas the opposite is not true. If you see i586 in this field and you're running the chip inside your computer is a 386, this package will not work on your system. Okay, so you need to get an architecture here that is compatible with the architecture that's inside your computer. Okay, so if you're running a Pentium, then you can handle something that says i386, or you can handle something that says i586. If you're running a PowerPC architecture, this thing here better say PowerPC. It better not say i586. Okay, and the reason that things are different here, the reason that there's different architectures here, is because the Pentium had more bells and whistles sort of in the assembly language than the 386 processor did. It had more directives to do things a little more quickly and slick. Okay, and if this particular package uses some of those directives for the Pentium processor, then it won't work on the i386 processor because the i386 processor doesn't have those directives or those assembly language commands. Okay. Following the architecture then is just .rpm, which stands for a Red Hat Package Manager package. Okay, so there is the layout of this. I think the most confusing part of this is that build number. Remember, that's not a sequential number, and if you're running a particular distribution of Linux, always look out for the coding in that build number for your particular distribution. If you don't see a build number out there for your particular distribution, like if you're running Mandrake and you look through this whole list of packages on the internet and you don't see anything that says MDK in it, well, that's probably because Mandrake and Red Hat are perfectly compatible for this particular package, and so it's fine to pick any of the build numbers because they're going to work on Red Hat as well as Mandrake. So before we move out to the Linux screen and actually carry out some of these commands, I just want to go through the RPM command set on the whiteboard here, just like we did for the Debian command set. So remember, for the Debian command set, the command that we actually typed at the command line was called dpackage. Okay, for the Red Hat Package Manager, the command set, the command that you type up on the command line to do all your basic options is RPM, all lowercase. So here's some options, some of the basic options that you can use with the RPM command. -I is for a fresh installation. So say I want to install the Samba package on my system and the Samba package is not already installed on my system. Well, then I can install it with the -I option to the RPM command. So I would say RPM -I followed by Samba -2.1.0, etc. Okay, and that would install that version 2.1 of Samba, the package that I have. Okay, if a version of Samba already exists on my system, like an earlier version already exists on my system, then I can't use the -I option. -I is only for fresh installs. If I want to upgrade some existing installation, I can use -U or -F. -F is specifically for upgrading. So if I know that there's an old version of Samba on my system, I want to upgrade to the new version, I say RPM -F, and then I give the package name of the new Samba version. Okay, capital U here is really a combination of I and F. So capital U will do a fresh install, or it will upgrade an existing installation, whereas I will only do a fresh install and capital F will only upgrade an already installed version. Okay, so that's how you upgrade or install a package with RPM. Then there's the -Q option, which queries a package. So you've got some RPM package on your system. You can query that package with the RPM -Q option. That will give you information about the package, like, is it already installed? What files are part of this package? Things like that. Okay, so that's how you get information about a package, and we'll do this when we get out to the Linux screen, and you can see exactly the kind of information you get. Finally here, we've got the -E option, which does an uninstall of a package. Okay, so there's your basic RPM command set, and just like in the Debian command set, these are the, there's basic commands, and then there's also fine-tuning commands. And I've listed out 3 of the fine-tuning commands for the RPM command set. The first one here is --force. Now, --force can be used with I, U, or F, the install or upgrade options for RPM. And what --force does is it will go ahead and force the installation or force the upgrade to occur. And what does it mean to force the installation to occur? Well, it will go ahead and carry out the installation even if that means overwriting or overwriting files or packages that are already in place on your system. Okay, what's the danger in forcing an installation? Say there's some package on your system, package X, and package X needs some library. And you want to install some Samba package, for instance, or some new package, and the new package that you're installing puts a new library in place that package X uses. Well, package X might just carry on perfectly fine with this new library in place, but package X might break with that new library in place as well. So if you just go ahead and do an installation, you don't use --force, it'll say, sorry, I have to overwrite this library and package X uses this library. If you say, what you should do at that point is back up that library, go ahead, force the installation, and then check out, the package you just installed, make sure everything works. If everything works great, then you should go ahead and test package X and make sure package X works with that new library. If it doesn't, then at least you have a backup of that library. You can put the backup back in place, you can restore that backup, and now your new package that you just installed isn't going to work. So then you need to weigh your options. What's more important, the new package that I'm trying to install or package X? And then you have to weigh it out based on your particular situation. But if you go ahead and do an installation and it says there's some problem here, there's some overwriting or something that I have to do, don't just force it without backing it up, because then package X might be a very important package on your system and you don't want to just, make it unfunctional. Okay? Same goes for --no deps. You should use that with extreme care. --no deps you can use with I, U, F, or E, the removal one. And what no deps does is it says don't do any dependency checks. So for installing or upgrading, if you say ignore dependency checks, then your package will go ahead and the installation will carry out, but it might not work because you didn't satisfy all the dependency information. Okay, so just because you say minus minus no deps, it's not some magic wand that you're waving over the package saying, oh, just don't use that library. I mean, it just can't work that way, right? I mean, you have to, these packages are built to use certain things, and if you say explicitly ignore this, either A, you're winging it and you're just hoping and praying that it works, or B, you're really knowledgeable and you know that that dependency information will never come into play for you because you'll never use the part of the package that requires that particular library or something. Okay, so again, use minus minus no deps with extreme care. Minus minus no deps works a little differently for minus E than it does for the install and upgrade options. Okay, so say we're uninstalling some package. We're uninstalling package X. And it says, well, you're uninstalling package X, and that's going to get rid of all this stuff. And package Y relies on some of that stuff. So by removing or uninstalling package X, you're actually going to break package Y. So if you say, go ahead, remove package X, say minus minus no deps, it's going to do it, you're probably going to break package Y. So this is a way, having this package management tool, one of the beauties of this is that this doesn't happen out of the blue, that package Y just doesn't break seemingly for no reason. Okay, it will tell you that package Y depends on this, and if you really want to go ahead and force that uninstallation of package X, go ahead and use minus minus no deps. But again, use it with caution because it can break things that are already functioning and in place on your system. A nice way to check out all this dependency information is with the minus minus test command. So you can go ahead and do an installation, do a removal, whatever, and use the minus minus test option with that. And that will just check for dependency information, but it won't actually carry out the install or the upgrade or the uninstallation of the software. It will just check. Sort of like the way that the Debian system had no act. It will go through and tell you what would have happened if it did the uninstall, but it won't actually break anything by doing it. It will just tell you all about the dependency information. Okay, enough of the whiteboard. Let's move out to the Linux screen and actually carry out some of these commands. Well, the first thing I want to do here is I want to talk about where do you get RPM files on the internet. One of the places you can get them is at rpmseek.com. And this is a search engine for RPM and Debian packages. So I'm going to open up this Mozilla web browser window that I've got going, and you can see if I scroll down that you can search for packages that are out there either by package name, so you can search for the package name directly, some file name that it contains. If you don't know the name of the package directly, but you know sort of what you want a piece of software to do, then you can click on the summary button there and then search for like a CD burner or MP3 player or something like that, and then you'll find in the English description of the packages, you're doing a keyword search basically like you would do on Google. Okay, so that's one way that you can search for packages out on the internet using rpmseek.com. What I'm going to do is I'm going to go down here to top 20 downloads. And I'm going to scroll down here to XMMS, which is an MP3 player for X Windows. Okay, now this MP3 player I already have installed on my system, but I've got an old version installed. I've got like 1.2.6 installed, and I want to upgrade to the newest version. So that's what I want to walk you through, how to upgrade this piece of software. So I'm going to click on XMMS, and what it's going to do is it's going to give me a whole slew of choices. All right, notice that it's found 160 RPMs for XMMS. Now these are not all different. What they are is they're different distributions or different versions or for different architectures, things like that. My version that I want to grab is right here, 1.2.10. Okay, that's the newest version of XMMS, and that's what I want to grab. All right, you can see it's for an i386 architecture. Notice also over here it says Fedora Core Development. Fedora is like the non-enterprise version of Red Hat now. That's what they're calling the non-enterprise version of Red Hat. So this is what I want to use since I'm running Red Hat Linux. Okay. One of the things that we didn't talk about down here is like the SRC type RPMs. Okay, so in the architecture field, it could also say SRC instead of, PowerPC or i386 or something like that. And when it says SRC, what that is it's source code. So if you get source code for a particular RPM, then you have to compile it yourself. Okay, now the reason you might want to do that is if you're a programmer and you like to mess around with things and customize stuff, then you can get the source code and alter the source code and mess with it and customize the actual code. Okay, that's one of the nice things about Linux if you're a programmer. You also can get the source code if you're having problems installing a particular binary, or if you just don't find a binary version for your particular architecture, you can compile it specifically for your architecture from the source code. Okay, and we'll talk about that in some other nugget. All right, so what I'm going to do is I'm going to go to this i386 one here, and before it starts downloading, what it's going to do is it's going to bring up this information screen. Okay, so it's got all this information about this thing that I'm downloading, this package. Okay, what size it is, what architecture it's for, what the copyright is, like the GNU public license, things like that. Okay, it has a little description of what it is. What I want to concentrate on is this requires field. Okay, in this requires field, it's listing packages that you have to have installed in order to run your XMMS package that you want to, the new version of that. Okay, so it's saying you have to have this package called GTK plus. So first of all, what we're going to do is we're going to go test in a different window here. Let me go to a different workspace, and I've got a terminal window here. I just want to search and see if I've got the GTK plus package installed. So I'm going to say RPM minus Q. Remember, that's how you query about a particular package. Hit enter, and it tells me exactly what version of this package I have installed. If you want more information from minus Q, you can use it with also the minus I option. So you can say minus QI, and that will give me even more information about GTK plus, and hit enter. It'll tell you all sorts of things like when it was installed, the various size of the file, the little description of what the GTK plus package is, and you can see it's a library for creating graphical user interfaces. Okay, so check mark. Okay, we're done. We found GTK plus on our system. Next is unzip. So let's go back to our terminal window. Let me clear the screen so it's a little bit easier to read. Minus Q unzip. Okay, RPM minus Q unzip. It's telling me I have version 5.50 of unzip. Perfect. Check. Next one. All right. The next one here, let me scroll this window over so you can read it all, is /user share desktop menu patches / Red Hat audio player .desktop. This is not a package. This is a particular file that you have to have installed on your system so that you can run this XMMS. Okay, so all I'm going to do here is I'm just going to cut and paste this. Okay, so I'm just going to highlight it with my mouse, leave it alone, come to the new window, say LS, and then hit the middle mouse button, and then it takes that stuff that I highlighted and pastes it right on the command line. I'm going to hit enter, and it listed it. So I said list the files that match this. It listed one. It didn't say file not found. So that means this file exists on my system. Check. Next thing. Okay, Red Hat menus, that's another package. I can go back to that terminal window and type RPM minus Q, Red Hat menus, and it would tell me the version of Red Hat menus that I'm running. Okay, sbin ld config is another library, so I would do it like I did this one up above. I would just highlight it, do an ls, make sure that ld config file exists in the /sbin directory. All right, great. So if I go through all those, which I did before I actually started this little segment, I checked to make sure everything was there. RPM lib is another package that if you do an RPM minus Q on it, you're not going to find it. And that's a little bit tricky or confusing for people. But if you have RPM on your system, if you've used RPM for anything, you've got RPM lib available to you. Okay, so this is just something that will come up in every package, and you've got it if you've ever used RPM at all. All right, so what I'm going to do now is I'm going to go back up here and I'm going to click this download button to download this particular version of the XMMS program. Once it's downloaded, I'm just going to pause and let it download. Once it's downloaded, then I'll walk you through how to upgrade my particular version of XMMS to this newer version. Okay, well now the download is complete. I'm going to do a listing of my temp directory, and you can see there's the file that we downloaded from rpmseek.com. All right, before we go ahead and do an upgrade, I just want to show you the current version of XMMS that I'm running is 1.2.7. All right, so there's the current version. I want to upgrade to 1.2.10. Now, a little pop quiz from 10 minutes ago. What is the RPM commands that we can use, or the options to the RPM command that we can use to do an upgrade from one version to a newer version? All right, well, we can use the -U option. And what else can we use? The -F option. Okay, so U is for upgrades and installs, and F is to freshen, okay, to upgrade an existing installation. And that's exactly what we want to do, is upgrade an existing installation so we can use either -F or -U. Before I actually carry out the upgrade though, I want to use this --test option, which I think is always a good idea, just so that you carry out that process and make sure that there's no dependencies, there's no other software out there that you're going to break. Okay, this is one of the reasons that we use a package manager, so that we don't install something and break something else and run into this vicious cycle of work to do. Okay, so I'm going to run the upgrade with the --test directive on the RPM file that I just downloaded. I'm going to hit enter, and notice here it says failed dependencies. There's an error. You don't have to worry about warnings, but errors are problems. Okay, the failed dependency is for ARTS 1.2.0. Now this is where you need to do some research. I didn't know what ARTS was when I got this error message when I was doing a dry run before I recorded this. Okay, so I went out on Google and I went out onto RPM Seek and I looked up ARTS, and I found that it stands for a real-time synthesizer, and it is a part of the KDE desktop environment. All right, so the K desktop environment uses ARTS in some of its sound things. I don't use the K desktop environment, I use the GNOME desktop environment, so that conflict did not bother me. So now I'm saying, okay, that's fine. I don't care that this conflicts with XMMS. I'm going to go ahead and do the upgrade anyway. So I'm going to say RPM -F, but what other option now do I have to give to the RPM command so that it carries this out? If I just typed here XMMS like this and I hit enter, I'm going to get this exact same dependency failure, and the upgrade will not complete. I need to put something else in here to make this go through, and the thing I need to put in there is --no deps. Remember, this ignores dependency information. This says forget about dependency information, and basically when you write this, you're saying I'm confident that whatever this breaks, I don't really care so much about. Okay, so what I'm going to do now is hit enter, and then as this is upgrading here, I'm going to pause the video and we'll come back when it's complete. All right, well, the upgrade is complete. That didn't take more than 15 seconds or something. And now the XMMS is at the version 1.2.10. To verify that, what I want to do is say RPM -Q, XMMS, and now you'll see I've upgraded to XMMS version 1.2.10. Okay, so that's all it takes to do an upgrade once from an existing piece of software, an existing package on your system, to a newer one. All right, always remember to do that --test to make sure that whatever dependency information is out there, that you check it out thoroughly before you follow through, and especially before you follow through and do something like --no deps. Now there's a lot more to the Red Hat Package Manager and the Debian Package Manager than what we got to cover in this particular nugget. We covered the most basic options, the most important ones, the ones you're going to use 90-some% of the time, that are going to cover, querying information about packages, installing, upgrading, removing packages, that sort of thing. But if you need more information on the RPM command or the dpackage command, the best place to turn right off the bat is the man page for the particular command. Now this man page is gigantic. There's pages and pages and pages of information in here. There's hundreds and hundreds of different options, but it's organized in such a way that makes it very easy to cut to right what you need. Okay, and I want to show you how this is organized. So first, there are the querying and verifying packages options for the RPM command. The only one of these options that we talked about was -Q. There's also a -V, a verify option, which is important, and that verifies the integrity of a package. It makes sure that if the package is installed, it checks that all the files are present and makes sure that they're unchanged since the installation took place. So you can see if a package isn't working, you can run the verify option on the package to see if something's been corrupted in the interim between when you installed it and now when it's broken. Okay, so let's go back to this -Q option. Now for the minus Q option for RPM, there are these fine-tuning options, what I was calling fine-tuning options. There's a whole group called select options, and there's a whole group called query options. Let's page down to that subsection of the man page, and here they are. Here's the select options, and here's the query options. Okay, what do the select options do? Well, they allow you to pick which packages you're talking about, which packages you want to query and get information about. Okay, and you can either give just a package name, which is like what we've been doing, like XMMS, or you can do something like give a -a to query all the packages on your system. Okay, and there's other options in here on how you can select which group of packages you want to talk about. And then once you select which group of packages you're talking about, there's this whole thing on query options. Okay, this is the other thing that goes with the -q command. All right, so you can, the only one we've used in here is the -i or info. So we saw when we packaged -i with -q by saying RPM -qi, we got a whole bunch more information than just -q gave us by itself. Okay, and you can see there's other things in here. You can get the config files for a particular package, or the doc files, which are the information on how to use the particular package, things like that. Okay, so that's how you sort through this man page. You can see here if we go down and look at the installing, upgrading, and removing packages options like -i, u, f, and e. We learned about all of these. Then what goes with those are install options. At least these three, you can choose from any of the install options category to fine-tune this command that you chose. Let's page down to the install options, and the only ones of these that we've seen is --force, --no deps, and --test. But you can see there's a whole bunch more there. So if you're doing an install or an upgrade and you want to tailor things a little bit more fine, you tailor things a little bit more, then go down and look through this man page to see exactly what kinds of options you can package up with -i or -u or -f to make it do what you want to do. Okay, so that's how this man page is organized. That's how you cut to the chase and get to the information that you're going to find critical for your particular application. All right, well, it's time to wrap up our nugget on package management. We started by talking about the Debian package management tool. That's called apt, which just stands for a package tool. We learned about the commands that you can use in apt, and the command that had the most options that you'll use the most often is called dpackage. And that had options to do things like install and upgrade and remove packages from your system. Then we moved on and talked about the Red Hat package management tool, and the command that you use there most often is called RPM, and there's options there to do similar things like Debian did. Install, upgrade, remove packages, get information about packages, that sort of thing. The biggest tip that I can give you is always test for dependencies and conflicts and so on before carrying out a particular operation, whether it's an install or a remove or an upgrade or whatever. And the reason for this is because, if you're not doing this, then you might as well not have a package management tool in the first place. One of the reasons that we like to have a package management tool at our disposal is because it just simplifies this whole process of keeping track of software on your system. Nowadays, the way that software is designed, there's so many shared libraries. Software is so modular and it reuses so much code that keeping track of which pieces of software use which shared libraries would just be a nightmare to do in your head or in a notebook or something. And this database that each of these package management tools keeps track of does this for you, and it lets you know whenever there's a problem, whenever there's a shared library that you're going to overwrite that other software uses. And this allows you to be very efficient and thorough in your testing, so when you see a particular library is changing and it's going to affect all this software potentially, you can go ahead and do the upgrade and then go and you know exactly which pieces of software to test to make sure that that software is still functioning with the upgrade of some other software. All right, well, I hope you found this nugget informative, and thanks for watching.